Today we're going to be discussing how forces act on a system. The purpose of this lab was to demonstrate how different forces affect the trajectory of a system or an object. We used two coded models, one being a black hole that was orbited by a star, and then the second model was a spacecraft that was launched off the moon and then orbited the moon and the planet. Some physics fundamentals to understand is the gravitational force equation and Newton's second law of motion, and some other key equations that are shown later on. And here are the results of our lab. The data we collected was that the black hole's mass was as shown, and the initial velocity of the spaceship was as shown. And we might have slight errors in the mass of the black hole because we did take the average of all the masses that were given to us in our data collection. Now here is our model for the black hole. As you see, the black hole was orbited by a star. And the errors you see is the orange being F net and the cyan being F net perpendicular. And there was a purple arrow, but you do not see it here because the code is finished, but it was F net parallel. And we created that using GlowScript. The key formulas are as shown below. These are both momentum principle formulas. As you see, we first initialized the data in our code, and then we have the velocity, and the initial velocity, which is the initial conditions of the star, and the initial position of the star would have been 0, 0, 0 in our orbit. And then we have the initial velocity, initial and final velocity to calculate the momentum of each one. And then we use the momentum to calculate the F net. And then we use these and other formulas for F net parallel, and then F net equals F net parallel plus F perpendicular, and then the gravitational force equation. First, we use the formula to calculate F net parallel, and then we find F net perpendicular with F net minus F net parallel, and then we rearrange the gravitational force equation to find the mass of the black hole, and we use F net in replacement of the gravitational force because that is the only force acting in that direction. And then this code makes the arrows that you saw before. Now, what does it mean? We are asked, what is the difference between, or how do we compare the parallel and perpendicular components of the forces versus the net force versus the change of momentum? Now, the parallel components of the objects changes the object's speed, and the perpendicular component of the force changes its direction, while the perpendicular component of momentum is the motion in one direction, while parallel component of momentum represents the motion of direction of travel. Now, there are no similarities and differences in the model because we have nothing to compare it to, and we might have slight errors in the math as stated. Now, here's the model for our spaceship that is launched off the moon and then orbits the moon and the planet. As you see, the trajectory is all out of whack because it is being affected by both the gravitational force of the moon and the planet. And here are the key formulas we use for this code. First, we have where we iterate all the initial conditions, and then we have the speed of the moon, and then we have the initial conditions of the ship, where the initial position was the moon and the velocity as is shown, and then we use all this data to find the force on the planet on the moon and the ship to the moon to have the F net of the moon, and then we have the key formulas here to help us find the F net of planet on the ship and then moon on the ship to find F net of the ship, and then we have the position update formula and velocity update formula for both the moon and the ship. Now, our what if. What if we had a system in space where we had a black hole, star, planet, and a moon? You have to think, firstly, of the hierarchy of forces and which force is greater than the others. Well, first, you have all these forces that I listed that act upon each other. And I believe that the black hole would be the center of this system with the star orbiting it and maybe the planet orbiting the star. And that's how the system would look. Now, we were predicted to have a figure 8, but as you saw, our trajectory was not very stable and it moved throughout. It did not have a very stable figure 8, but it did have orbiting both the moon and the planet at one point. And we have slight errors in the trajectory, but that is not anything crazy. We performed this to observe how different forces act on the trajectory of an object. The results were the mass we found of the black hole and the initial velocity of the spaceship, which is the initial conditions. And the errors were as stated. We had slight errors in the mass and slight errors in our trajectory. Thank you.